Alright, in the last lecture we have learned what is a stack and why we need it. Now starting from this lecture we will learn the common operations that can be performed on stacks. So these operations include creating a stack, push method in stack, pop method in stack, pick method in stack, isEmpty method, isFull method, and delete stack method. Now we are going to explain all these methods one by one over here, then we are going to implement them in practice. To create a stack, we just need to initialize an empty array or linked list inside stack class without any element in it. We just need to call the custom stack class and our stack will be created in the memory. So right now we have an empty stack, so the first operation that we will perform on this stack is push method. So in the world of stack, when we say the word push, we basically mean to insert. Similarly, when we say the word pop, we basically mean removing an element from the stack. So let's see how push operations work in stack. So we have an empty stack like this. So when we insert the first element in this stack, it's going to locate it in this memory like this. So if I push the one to this stack over here, it's going to insert at the memory like this. So as you see, one is inserted to the custom stack over here. Now if I insert second element using push method over here, the second element will be located at the top of previous element in the memory. Now whenever I call push method with any given parameter over here, it's going to insert an element at the top of previous element. So for example, if I continue to add 3 to this stack over here, it's going to insert 3 at the top of 2. Then if I continue to insert 4 over here, it's going to insert 4 at the top of 3 over here. So this is how our stack will look like in our memory. Now we have inserted these 4 elements to this stack over here. So it can be easily see that the elements are located on the top of each other. So here it's obvious that when we are pushing an element to the stack, any given element will be located on the top of previous element. So this is how push method works in case of stack. Now let's continue to the next method, which is pop method. Now we have already said that in the world of stack, instead of remove, we use pop. So here we have the same stack that we created and inserted elements to it. Now in this case, we are going to run pop method for this stack over here. Now as we mentioned before, stack works the way last in, first out. So the last in element that we have inserted is 4. So the first element that will come out will be the 4. So if I call pop method over here, first it's going to return the 4 and 4 will be deleted from the stack over here. Now the way that the pop method works is like this. First it's returning the last element, then it's deleting that element from the memory. Now if I call pop method one more time, it's going to return 3 in this case because the top element is 3. The last element in this case is 3. So it's going to return 3 and 3 will be deleted from the memory. Then if I call pop method one more time, 2 will be returned and 2 will be deleted from the memory. Now you see that we have only one element in our stack. Now if I call it one more time, it's going to return 1 and 1 will be deleted from the memory. Now you might be interested that what if we call pop method for empty stack over here. So if I call pop method one more time, it's going to give an error saying that the stack is empty. So it's not going to return anything and it will say that the stack empty in this case. Now let's continue to the next operation. So the next operation is pick method. Now pick method works different from the pop method. Here also it returns last inserted element in the stack, but in this case it's not deleting the element from here. So if I call pick method in this case, it's going to return 4, but 4 will not be deleted from the memory in this case. So if I call pick method multiple times in this case, it's going to always return 4 because 4 is not removed from the memory over here. Now here you might be interested, why do we need pick method? So in some applications we might just want to check the top element in our stack without removing it. So in this case, the pick method becomes very useful. So pick method returns the last element without removing it. Now let's continue to the next operation. The next operation is empty method. So this method is used inside another method to check elements in the stack. Because if there is not an element in the stack, it does not make sense call other methods over here. Now in our case, if I run isEmpty method for this stack over here, it's going to return false because in this case our stack is not empty. So we have elements in our stack, so this means that the return from this method will be false because this stack is not empty. Now the next operation is isFull method. So similarly we are using this method inside other methods. So if our stack becomes full, In this case, it's going to return true. So how do we know that if our stack is full or not? So in this case, if we are implementing stack using arrays, in this case, we have fixed size of elements in our arrays. So this means that when we reach that size, the return from this method will be true because the stack is full. Now in this case, if we run this for this stack over here, it's going to return false because in this case, our stack is not full. Now when we are going to implement our stack using linked list, in this case, we don't have to implement this method because it's not going to be full ever. That's why this method does not make sense in case of implementing linked list. But when we are implementing using it array, so this method becomes very useful because if the stack is full, we cannot call push method to push some elements to our stack over here. Now finally, the last operation is, now by using delete method, we can delete entire stack from the memory. So to delete an entire stack, so we just need to delete array or linked list from the memory. So with this, all elements of stack gets deleted from the memory. Now if we call this method for this stack over here, all elements will be deleted from the memory. Now with this, we have come to the end of this lecture. So in this lecture, we have explained the operations that we can perform on stacks. So we have shown you how the operations works in the memory when we call them for this custom stack over here. Now from the next lecture, we are going to implement these operations in practice using arrays and linked lists. So see you in the next lecture.